In my book for this topic, I give a quite involved example of packaging, and I just thought I would sort of talk through that a little bit here in this video. Here's a can of Progresso white clam sauce, and now what went into making this can? There is the material which the can is made out of, and I don't know what they make these out of. When I was a kid, we call them tin cans, but I'm not sure that's all tin. It might be aluminum, some other kind of alloys. It's I'm sure it's a cheap metal that doesn't corrode, and that's why it's chosen. So the material for the can would be based upon its surface area, both the sides, tops, and the bottoms. Now it's possible the top and bottom might be made of different material, might cost differently. That would be an additional consideration. The putting the can together requires fastening it at the top and perhaps at the bottom, although this, I can't tell. This almost looks like it was somehow made out of one piece. I'm not sure how they could do that. But I'm going to assume that the bottom is welded on and the top is welded on. However they do that, I'm not quite sure. But those costs might be associated with length, circumference, and welding. And then there's the label. Don't forget the label. The label cost is based upon the surface area along the side of the can. And because of all that ink and printing costs, and then you have to glue it on. Also, by the way, the can, I believe, probably has a seam along the sides here. And so the side is probably a rectangle that's folded around to make a circle, and it's attached along the seam, and that's another length measurement. So I have length measurements, I have area measurements, and my constraint in this case has to be volume, because this holds 15 ounces, I believe. And so the volume, can only contain 15 ounces, so that's a constraint in the problem. All right, so what made them decide to package the can this way? All right. Well, this might be the cheapest way they can do it. I don't know. But if you wanted to know the cheapest way to do it, based upon all the costs involved, you would need to construct a function of a single variable. And perhaps maybe the radius of the can or the height of the can. And if once you have that function, then you can use methods of calculus to determine the minimum cost. So that may be how cans, the shapes of cans evolved, at least initially. For example, the sardine can is recognizable everywhere. It's pretty unique. It's a rectangle with rounded sides. It's flat. Usually has a pull top. This one does. At least nowadays they do. I think originally you had to use a can opener. And why are sardines packed like this? Well, when people first started packaging sardines, the cost of the sardines was less than the stuff they would put in with them, like the oil or any other kind of filler they put in. And so if they put in some kind of oil with the sardines, like this one has, soybean oil in it, then it was to their advantage to pack it more with fish, because that was cheaper. And so they probably determined that through experience and maybe a few calculations that this was the most efficient way to cram 3.75 ounces of sardines in a can. And now these days it made the shape of the can maybe more psychological, because all sardine cans are supposed to look like this, right? There may be a marketing thing there, because if you started seeing sardine cans appear like this, would you buy it? All right, I know a lot of you wouldn't buy it anyway because you don't like sardines, but I happen to like them a little bit once in a while. But that doesn't look like a sardine can, so would I pick this can? Well, I might, because I'm different, but probably most people would think, you're kidding, that's not sardines. Anyway, matter of fact, this was Kroger Ripe Olives, a little short stubby can, and it's probably short because it doesn't hold much. It holds 2¼ ounces. And that's the weight, not volume. So I'm not sure what the volume is without doing some measurements. But anyway, this, if you made it taller, it would be a thin can. It probably wouldn't stack very well. So this, I imagine, had to be flat in order to stack. But here's Del Monte fresh cut green beans, and it has a pull tab that adds to the cost. So all these things I'm discussing here, the cost of making the can, if you wanted to make a cheaper can, then you have to be able to quantify all those costs. You have to be able to write them all in terms of a function, and then and that's doing math modeling. And then you can optimize it. In other words, use methods of calculus to figure out the cheapest way to package it. So anyway, I wanted to talk about that as a real world application. And again, I encourage you to try to read through my problem in my book, or actually work one of these problems. So okay, well, that's math modeling. It's taking physical situations and turning them into mathematical functions so that we can later on analyze them and solve very interesting problems.